Welcome back to Stack Lessons. In this lesson, we're tackling final review, the Amazon Web Services Certified Data Engineer Associate Exam Cheat Sheet in 15 minutes, one of the trickier topics on the exam. Let's break it down. By the end of this video, you'll have every decision rule from the Amazon Web Services Certified Data Engineer Associate Exam compressed into a 15-minute checklist you can replay the night before the test, and again on the morning of. Nothing new, no deep dives, just the rules that decide answers. Let's run the checklist. Think of this like a pilot's pre-flight checklist. You're not learning to fly right now, you already know how. You're just running through every switch and confirming it's in the right position before takeoff. If a rule on this video surprises you, that's your signal to go back to the full episode for that service. Otherwise, just nod along. Here's how to use this video. Watch it the night before the exam and again the morning of. That's the rhythm. Each service gets 30 to 60 seconds, and we're only covering decision rules, not mechanics. At the end, we close with 5 exam day rules. Those final slides matter more than anything else. And if any rule along the way feels unfamiliar, pause, go back to that full episode, and come back. Glue in 6 lines. Crawlers infer schema and register it in the data catalog. ETL jobs run your Spark and Python transforms. Job bookmarks track which files you've already processed, so incremental loads don't reprocess yesterday's data. Flex execution gives you about 34% off data processing unit pricing, or DPU pricing, for non-urgent jobs in exchange for variable start times. DataBrew is visual, no-code data prep. It is not governance. And if your Glue job runs in a VPC, the subnet's root table needs either an S3 gateway endpoint or a NAT gateway, or the job fails before it even starts. The one Glue distinction to internalize: DataBrew is data preparation and lake formation is governance. If the scenario uses the word governance, access control, or fine-grained permissions, the answer is never DataBrew. Different verbs, different services. Kinesis splits cleanly into 2 services. Data streams is the real-time side, around 200 milliseconds classic or 70 milliseconds with enhanced fan-out. It supports multiple consumers, it's shard-based, and retention runs from 24 hours up to a full year. Enhanced fan-out lives here and only here. Firehose is the near real-time side, 300 seconds of buffering by default, configurable anywhere from 0 up to 900 seconds. It delivers to a single managed destination, has no retention and no replay, and it can convert records to Parquet in flight. The Q word does the work. Real-time means data streams. Near real-time or deliver to S3 or managed delivery to a destination means Firehose. If the scenario mentions multiple consumers reading the same stream independently, that's enhanced fan-out, which only exists on data streams. Athena in 4 moves. Partition projection is for tables with massive partition counts. Athena infers partition values from the S3 path pattern, so it never calls glue get partitions. CTAS, meaning create table as select, is your conversion tool, CSV to Parquet, creating partition tables, materializing results with a 100 partition limit per statement. Workgroups give you per team isolation, and byte scan cutoff per query is the guardrail for cost control. And the format default, Parquet plus partitions, is almost always the right answer. Redshift distribution styles, 1 decision rule each. Key distribution hashes rows on a join column so joined rows land on the same node. Use this for large fact tables. Even distribution spreads rows round robin for balanced storage. Use it when a table doesn't participate in joins. All distribution replicates the full table to every node, eliminating shuffle, but only for small dimension tables, because storage multiplies by cluster size. Auto is the default. Redshift picks and adapts the style as the table grows. Sort keys and spectrum on one slide. If you don't specify a sort key at all, the table defaults to auto and Redshift decides whether to apply one for you. When you do declare a sort key, compound is the default sort type. Best when queries consistently filter on the leading columns, like a phone book sorted by last name then first name. Interleaved gives equal weight to each sort column, but running a vacuum reindex is 4 to 5 times more expensive, so it's rarely the right answer. Now spectrum. Spectrum external tables support select and insert for Parquet and text formats, but you cannot copy into them and you cannot update or delete rows. And Spectrum cannot read objects stored in any Glacier class. They have to be restored to S3 standard first. From the Redshift documentation, Spectrum external tables let you select and insert, and you can use create external table as select for Parquet and text formats. What you cannot do is copy into an external table, and you cannot update or delete rows. So if a scenario asks for bulk loading through copy or in-place row updates against an external table, those answers are out, even though plain inserts are on the table. Lake formation 5 rules. It is always the answer for data lake governance. Never IAM alone, never bucket policies alone. It provides table, column, row, and cell level security. LF tags let you grant permissions by tag rather than by named resource, and tags inherit from database down to table down to column. You have to revoke the IAM allowed principles default permission first, or your fine-grained controls get bypassed. And it's enforced uniformly across Athena, Redshift Spectrum, EMR, Glue, and QuickSight. Any question about fine-grained access across multiple engines points here. And here's the official wording. Lake formation enforces permissions at the column, row, and cell level across Athena, QuickSight, Redshift Spectrum, EMR, and Glue. That sentence is your tiebreaker. Anytime a question describes fine-grained access on a data lake that multiple engines query, lake formation is the answer. S3 cost optimization comes down to one decision. Lifecycle policies are calendar-based. After 90 days, move to Glacier. Use them when the access pattern is known and predictable. There's no monitoring fee. Intelligent tiering, on the other hand, watches how each object is accessed and shuffles it between tiers automatically. Use it when the pattern is unknown or unpredictable. It charges a small per-object monitoring fee, which makes it not worth it for objects under 128 kilobytes. Glacier retrieval times memorize this matrix. Flexible expedited returns your objects in 1 to 5 minutes, the only sub-hour option. Flexible standard takes 3 to 5 hours. Flexible bulk takes 5 to 12 hours when cost matters more than speed. Deep archive standard takes approximately 12 hours. Deep archive bulk can run up to 48 hours. Match the retrieval window in the question to the right row. The detail people miss: Deep Archive has no expedited option at all. The fastest you can get data back from Deep Archive is roughly 12 hours. So if the scenario requires retrieval in minutes, Deep Archive is gone, period. Expedited only exists on Glacier Flexible Retrieval. DynamoDB 5 rules. It's an OLTP key value store, not an analytics engine. If the scenario mentions aggregation, joins, or a data warehouse, DynamoDB is the wrong answer. Streams give you change data capture with 24-hour retention and ordered item level changes. TTL is a free background cleanup mechanism. It doesn't consume capacity, and deletes appear in streams as remove events. DAX gives you microsecond reads, but only for eventually consistent ones. And the gotcha, strongly consistent reads through DAX pass straight through to DynamoDB, so DAX doesn't help. And here's why from the DynamoDB docs themselves. DAX can't serve strongly consistent reads on its own because it isn't tightly coupled to DynamoDB. Strongly consistent reads pass through to the source. So if the question pairs strong consistency with DAX as a latency fix, that's a distractor. Security 5 rules. SSEKMS logs every encrypt and decrypt operation in CloudTrail, giving you a full audit trail. SSES3 has none of that, so when the scenario demands audit, the answer is KMS. Secrets Manager handles credential rotation. Parameter store secure string is for static configuration. Gateway VPC endpoints are free, and they only exist for S3 and DynamoDB. Everything else uses paid interface endpoints over private link. And DEA-C identifies sensitive data. It never redacts or removes it. The DEA-C rule is a verb test. Discover, classify, identify, that's DEA-C. Mask, redact, remove, transform, that's something else. Glue with the detect PII transform, a Lambda function, an S3 object Lambda, or a DataBrew recipe. If the question asks you to actually change the data, the answer is never DEA-C. 1 slide, 6 mappings. Real-time means Kinesis data streams. Near real-time or deliver to S3 means Firehose. Row, column, or cell-level security means lake formation. Unknown access pattern means S3 intelligent tiering. Audit who decrypted data means SSEKMS. And cheapest private S3 access from a VPC means a gateway endpoint. 6 Qs, 6 answers. Most scenario questions hinge on one of these. Now the most important part of this video, 5 rules to carry into the exam room. These aren't about knowledge. They're about discipline. They're the difference between knowing the material and actually scoring on it. Rule 1. Read the qualifiers first before you even read the scenario. Most cost-effective, least operational overhead, real-time, fastest, most secure, these qualifier words decide the answer. 2 questions can have identical scenarios, and the right answer changes based on one qualifier. So train yourself, scan for the qualifier, then read the question with that lens already in place. Rule 2. Eliminate any option that uses the word manually. Manually trigger, manually scale, manually configure, manually restart. If there's an automated option in the answer list, the manual one is almost always wrong. Amazon Web Services questions reward automation. Cross out the manual answers before you even compare the rest. Rule 3. When 2 answers do the same thing, prefer the serverless or managed one. Athena over EMR, Glue over self-managed Spark. Firehose over running your own consumer. Lambda over EC2. Redshift serverless over provisioned. The only time you flip this is when the scenario explicitly rules out serverless, for example, sub-second latency at very high throughput, where Lambda actually breaks down. Rule 4. For any S3 archive question, match the retrieval SLA to the right tier. Minutes means expedited, which only exists on flexible retrieval. A few hours means standard. Half a day or more means bulk or deep archive. And remember, deep archive has no expedited option, so if the SLA is minutes, deep archive is eliminated before you even look at cost. Rule 5, and maybe the most important one, never burn 5 minutes on a single question. If you've read it twice and you're stuck, flag it, pick your best guess, and move on. Come back at the end. The exam uses compensatory scoring. Only the overall score has to clear the threshold, and finishing the exam is worth more than perfecting any one question. The 5 rules in order: read the qualifiers, the phrase decides the answer. Eliminate manual, automation wins. Prefer serverless and managed by default. Check the retrieval SLA against the right Glacier tier. And flag tough questions and move on, because finishing the exam is the point. Run these 5 during every question. You've worked through 25 episodes to get here, and the patterns are already in your head. On exam day, run the 5 rules. Read the qualifier, eliminate manual, prefer serverless, check the retrieval window, and flag the hard ones. When a question feels close, trust the decision rules over your gut on the scenario. You know this, go pass. That's it for final review. The Amazon Web Services Certified Data Engineer Associate Exam Cheat Sheet in 15 minutes. Drop a like if this clarified things. Subscribe so you don't miss the rest of the Amazon Web Services Certified Data Engineer Associate, and I'll catch you in the next video.